Hi there, I'm Ryan. I'm an mlpack maintainer, and in this video, I'm going to show you how you can develop mlpack and contribute to the library. So I'm going to do some basic changes to the library, and then write and run some tests. And these changes won't be useful, per se, but they will give the basic idea of contributing to the library, and if you do want to contribute, you can base what you do on this workflow. Now, everything I'll do in this video is from the command line. That's my preferred workflow. But I do get that that's not everyone's cup of tea, so I also recorded this video doing the same thing, but inside of an IDE, specifically VS Code. So you can see that in another video. All right, let's jump right in. The first step is going to be to get the code, or clone the Git repository. And so now you could do it like this, and this would be the standard way. But actually, I have Git set up, my GitHub connection is set up with an SSH key. So I will actually clone the mlpack repository like this, which will ask me to enter my key. So whether or not which method you use depends on how you have GitHub configured. But at the end of the day, you clone the repository one way or another, and now you have the mlpack repository. And so there's a bunch of stuff in it, and I'm not going to go through everything, but they're kind of two very important directories. One is doc, which has all the documentation, and the other is source, which has all the source code. So looking at the source directory, everything is under source/mlpack, and there are four important directories here. The first is the bindings. I'm not going to talk about the bindings in this video. The second is the core. This is the core classes of the library, things that aren't machine learning algorithms in their own right, but they're useful inside of and alongside machine learning algorithms. So things like probability distributions, distance metrics, math utilities, trees, kernel functions, other things along those lines. In the methods directory, this is where all of the machine learning stuff actually lives. There's one directory for each individual method, like decision trees in a directory. And there are a lot of files in that directory, and there are even some subdirectories, because the decision tree support in mlpack is fairly complex. Let's look at something a little bit simpler, which is the mean shift clustering algorithm. So just looking inside of a file, we can see that the class is documented, and there are a handful of functions. The first is a constructor, and we can see create a mean shift object and set the parameters that we'll run with. And it describes each of the parameters. Okay, so that's the constructor. And then we have this cluster function, which is what users will actually care about to do the clustering with mean shift. They pass in a matrix that holds data, and the method will find some clusters and fill the centroids matrix with the result. And there are a couple other options too. There are a couple versions of this cluster method, but most algorithms inside of mlpack kind of look like this. They have a constructor that sort of lets you configure how the algorithm is going to work, and then they have a function which does the work. So cool, that's roughly how things are laid out. There are also some auxiliary functions. Of course, there's lots of code in here that I'm jumping through. You know, a quick video isn't going to expose all the details about, what, 15 years of work or more. mlpack is big. Another directory I want to talk about is the test directory. Thinking of big, mlpack is, by volume, a lot of it is tests. We have in this directory, actually let's do it like this. How many files do we have in these directories? In the test directory we have 218 source files related to tests. A lot of tests. The tests are all written, so I'll look at the mean shift test. The tests are all written using the Catch C++ testing framework. And essentially, each test case is split into its own section. So here, I'm highlighting the entirety of one test case. And this test case is called, up at the top, it's called mean shift simple test. So it's a simple test for the mean shift algorithm. And it's in this test suite called mean shift test. And so it just creates a simple data set, and then the data set has 30 points. It has 3 classes. So we do the clustering with that cluster method, and then we just see, you know, did we successfully get 3 separate clusters, each of which corresponds to one of the classes. roughly, that's how all of the tests work. You know, there's something that's being tested. You build a data set, you run the algorithm, you do something. It can be more or less complex. Like down here, we have some other tests that are more complex. We like sample from a Gaussian distribution and make sure we can recover that, and so on and so forth. Every method is tested. That's a very important part of the code because that's how we know that it works. So let's build these tests now. In order to build mlpack's test, and this is documented in other videos and in the build documentation and the developer documentation on the website. The steps are to create a build directory for CMake. This will hold all of everything relating to the build. And then I'm going to run CMake to configure the library. But I'm going to specify build test equals on. And this is important to specify. It's not on by default because the tests take a very long time to build. And generally, if you're just using mlpack, you don't need the tests. So if you're a developer, though, you do need the tests. So you want to specify this build test is on when you configure CMake. And once that's done, you can then go ahead and build mlpack test, which is the one big program that has all of the tests in it. In this case, I've specified with make-j16 because the system has 16 cores. That will help this be a little bit quicker. But because mlpack uses templates, because Armadillo uses templates, and because there's just a lot in mlpack, this build process can take a little while. In fact, I think on this system, it'll take about 3 to 5 minutes. And I'm not going to make you sit here and watch the compilation go by, so I'm just going to skip to the end. Okay, so that took a little while, but it gave me time to refill my water, which was nice. Now we have an mlpack test program, and we could run it just by it gets put in the build bin directory. We could run it just like this. And so this that I've just run will run all of the tests for mlpack, but that, as I mentioned earlier, there are lots of tests, so that will take a little while. We don't want to do that. Instead, what we're going to do, if you saw all of the mean shift tests, let's go ahead and open this up. All of the tests have a test suite, like mean shift test, and all of the different algorithms are tests. They have test suites with names like this. We can run just one individual set of tests like this. Just specify the test suite. And we can see, okay, cool, that filtered down to run tests that are only in the mean shift test suite. And we ran 8 test cases, and there were 70 assertions. They all passed. Great. Now, let's see what happens. What does it look like when a test fails? So we can do this pretty easily by, let's find a test. Here's a test. At the end of this test, we're just checking that it was successful. So what if I just change that to say, check that success is false? Of course, this is not a good change, just for the sake of demonstration. I can rebuild the test, and this actually won't take very long. I have only modified mean shift test, and CMake is smart enough so that it doesn't rebuild any files we didn't need to rebuild. And now that that's done, I can rerun the mean shift test suite, and look, the tests fail. And in fact, 2 tests failed. Why did 2 tests fail? Gaussian clustering with float and Gaussian clustering with double. Well, let's take a closer look at it. The reason that 2 tests failed, so here is our Gaussian clustering test, is because this is actually a templated test case. So first it runs with an element type of float, and second it runs with an element type of double. So this allows us to test that mean shift works both when you're using 32-point floating bit numbers and 64-bit floating point numbers with the same code. So it's built on this template parameter elem type here, right? So that will be float in the first test and double in the second one, and the actual names will be a little bit different. In fact, if we wanted to run one individual test, Gaussian clustering float, we just pass in the name of it, and it runs only that one. Okay, cool. So I don't want to keep that change. Let's just revert it. I'll just check out the file. That was just for demonstration. Now let's make an actual change to the code base. Let's go into mean shift. And what can we do to mean shift? All right. So when we call mean shift, we specify the radius. and then the maximum number of iterations, and then a kernel if we want to use a kernel. The change I'm going to make is not useful. Please don't open a pull request that implements this change. I don't think it's actually a good change, but it's for the sake of demonstration. So I'm going to write the documentation for it first, and what we're going to change is if max iterations is 71, then an exception will be thrown because 71 is not a good number. I don't think I actually believe that, but again, for the purposes of demonstration. So the first thing we're going to do, we're going to write what we're going to do as documentation. Now, we can actually go modify the constructor. And so this is in the, so this header file, this meanshift.hpp, defines the class itself, and then meanshift.impl, the implementation, defines the actual implementation, right? So what we were going to do is throw an exception if max iterations is 71, then we will throw an exception. Throw standard runtime error. 71, or first, let's write a good error message here. Because C++ doesn't generally have a backtracing mechanism, it's important to put in the error message, like where is it being thrown from. So mean shift, 71 is not a good number for max iterations. I mean, again, as a user, I'd be very irritated if I got a message like this, but you know, for the sake of demonstration. So there's our code change, and importantly, we next need to make sure we have a test for it. So I'm going to write a simple test case. Test that an exception is thrown when an invalid value for max iterations is given. Okay, test case, invalid max iterations test. We'll put it in the mean shift test suite. And this test will actually be pretty simple. So I want to construct a mean shift object, and we'll give it a radius of 1.0 and 71 iterations. And is that all we need to do here? Yeah, that's all we need. Now we want this is going to throw an exception. So we can use the catch framework to catch or to check that an exception is thrown when you call the mean shift constructor with a value of 71 for max iterations. Cool. So now you can see the changes that we've made. We added documentation here. We added the code that does the thing. And we added a test. Let's add one more thing too. And this is an important thing. So the doc directory contains all of the documentation a user might see. This is how the documentation on the mlpack website gets built. And so each individual method is documented in doc/user/methods. So let's go into the mean shift documentation and let's make sure this is up to date. So we have some number of constructors here. Those are all documented. We have the parameters for the constructor. And a good place to put this note might be in the notes under the list of parameters to the constructor. Okay, so we'll just write a note. If max iterations is 71, then an exception will be thrown because 71 is not a good number. All right, so now if we take a look at our changes again, we see we've updated the user-facing documentation. We've updated the documentation that developers might see. We've updated the code with our change, and we've written a test for it. So now we can go back and we can compile it. And this will take just a little bit longer because there's an additional file of tests that we have to compile because we modified the mean shift class. But when it's done, mlpack test mean shift test. And we can see now instead of 8, we have 9 test cases, and everything works. Cool. So now that we've done that, this is our contribution. We want to submit it upstream to the library. We'll create a new branch. Let's call this branch mean shift max iterations exception, which is an okay name for a branch, I guess. And if I take a look, we have all of these files that we want to modify. And so let's go ahead and write a commit message. Modify or mean shift now throws an exception when 71 is given for max iterations. We can maybe add a little bit more. This is important because 71 is not a good number. I don't actually have anything against 71. Just an example. So once I've done that, cool, I've now made a branch, I push to it. Now I need to push this branch to my own fork of mlpack. So there are other ways to do this. I maybe should have set this up earlier, but I need to add a remote, which points to my fork of mlpack. And now I can do git push to the rcurtain remote. That's me. Push that branch there. So it will do that. And now if I wanted to open a pull request, I could just follow this link. You open the pull request, you just I guess in the pull request you would have to describe why 71 is a bad number if you want a maintainer to actually accept the pull request. Again, please don't actually submit a pull request with this in it. But hopefully this gives a decent idea of what roughly the workflow of modifying mlpack and rebuilding it as a developer look like, and what building individual tests and running individual tests looks like. There's, of course, lots more documentation, and one place you can find that documentation, it's on the website, and it's also in this doc directory. So in doc/developer, you'll find a handful of things here, files that you can also refer to that might be helpful. Okay, I hope that this video was useful, and as always, you can consult the website, or you can hop into the mlpack chat on Matrix to get real-time chat, or you can open issues on GitHub if you have any problems.